9:30, so we'll start. Yeah, so thanks for joining us, everybody, and it's great to see everybody interested in the new software control and UI. So thanks for taking the time this morning. So I want to introduce our Pocket NC crew here. So I'm Carrie, I'm in sales and marketing. This is John, he's in software development, and along with his team developed Kinetic Control. And then we have Q in the other square from applications team. So we also have Matt Rounds in our applications team who's in the chat. So you can ask questions there and he'll answer real time, or at the end we'll also have a small Q&A. So he'll just show up as Matt Rounds, Pocket NC. And I think Michelle might be lurking around here somewhere too, so she might also be in the chat. And there is a feature where you can push for a question, but you can also, there's like a question, you can designate your comment as a question, but you can also just put it in the chat. Great, so to get started, I just wanted to put up a quick poll to see how many people have used the previous user interface. So the Kinetic Control is new. Oops. There we go. Okay, so it looks like quite a few people have the Pocket NC, but a few are new. Great, thanks for doing that. So the outline for today, we'll start with John and talk a little bit about the development, and then he'll do a walkthrough of the new UI to give a feel for it. And then we'll move to Q, and he'll do a demonstration about the benefit of TCPC, which is definitely far and away the biggest new feature that's included. Great. So, John, why did we decide to develop the new control and user interface, and what are some features you think customers will like?
Yeah, so Kinetic Control, one of the biggest reasons we wanted to develop it was to plan for the future development. In the old software, we had a way to update fairly localized pieces of the software, but we couldn't update lower level features such as TCPC, BX unwinding. So one of the major features of Kinetic Control is its robust update system. Any file on the system can now be updated. So features like TCPC, we can roll out. If we find any bugs, we can release hot fixes. That's something that we believe in a lot, is to be able to support our customers in the field. So the update mechanism is great. We also want it to be very user-friendly and accessible. So we rebuilt our UI from the ground up with modern web frameworks, and hopefully it's intuitive and easy to use. And so TCPC, we've known we wanted from the beginning. So I think that's a key feature in this update, which Q will go over in more detail. But yeah, for the most part, it's to plan for the future. Like if you have any feature requests or ways to improve, definitely reach out. We definitely want to be able to add features and update features and keep it easy to use. So I can now go over the UI in general before we go into detail of what TCPC is. So yeah, when you first pull up Kinetic Control, you'll be put onto this manual tab here. And this is where you can control the machine by issuing manual commands, jogging the machine. For starters, you're going to have to take the machine out of e-stop and then home the machine. So it'll find all the home switches. The homing process generally takes a little bit longer than that on a real machine, but Once you're homed, you can then jog the machine. So right now I'm just kind of pushing keyboard buttons to jog individual axes, but we definitely wanted the UI to be mobile friendly. So for touch devices, so you can just click and drag any one of these digits to move a very specific amount, or you can jog continuously by just clicking these buttons down here. And all of these interactions can be bound to key bindings, which makes it really easy for someone in the field to create their own like pendant. They could just hook up a keyboard and bind specific key bindings. Actually, if you check out our forum, someone posted today about their little Raspberry Pi project that has a custom keyboard with all the bindings to manually control the machine. So we wanted that to be really flexible. We also have this MDI interface, which is improved from the previous software. So any MDI command that you enter here will go into your log of commands. If you find yourself using commonly used commands, you can favorite them here, which will make them appear in your favorites list. And if you click on your favorites, it will just bring that command up to the bar here, and you can add to it or edit it. If you want to make it more immediate, you can name it here, and it will appear in your quick access tab. And then it's just a button, one less click. You can just click that and it will issue it immediately, which can also be bound to a key. So this should improve workflows. Like if you, so you don't have to just type in commands. You can make it really simple to have commands that you use often. The system tab has ones that we use here in the shop during calibration and assembly. So you can do the same with your own commands here. The next tab you'll probably use is the setup tab, where you'll set up work offsets for setting up part programs. Q will be going over how to use this with TCPC to make your machining life easier. Of course, tool length offsets here as well. You can make those active, probe the tool, measure it, and you can see that offset up here as well. So after your offsets are set up, you'll generally go to the production tab. This is where you can open G-code programs, upload new programs. This one's fairly big, so it takes a little bit of time to upload, but we can just pull that one up, run it, and you'll see these gauges. We don't have a real machine hooked up, so some of these gauges don't have values in them, but and we didn't have the right tool populated, so we got an error there. But these gauges are really helpful for proofing out a program. We wanted to put information like chip load, so this takes into account the feed rate, calculated feed rate of the program, the spindle speed, and the number of flutes that you specify in your tool table here. So you can get that information, your surface speed as well. These are calculated based on what your machine is doing at any given time. The center value here, the feed rate, is a calculated feed rate based on how fast your rotary axes are moving and your linear axes are moving to give you an instantaneous feed rate, calculated feed rate. So it may differ from your commanded feed rate, which you can see in your active codes down here in the bottom left. But it could be a great way to know that you're not actually reaching your commanded speed. So it's great to look at that. Same with the spindle speed. If your machine has the sensors on it to calculate spindle speed, which so older V1s and initial V2s, I think, don't necessarily have that information. But if you do, you'll see a calculated spindle speed rather than the commanded spindle speed there. So that can give you some great information while machining. We've got sliders here, just like in the old interface. an additional one with max rapid to override the speeds. So that can be really helpful to adjust those while you're proofing out a program and figuring out your feeds and speeds. So yeah, overall, just new interface there. We have some messages down here in the bottom right. So those errors that we ran into are displayed there. I can clear them to make sure I acknowledge them. Same with the info messages. We successfully uploaded this file. All of those messages are also logged in this history tab. We have other plans for this tab to track other information, but for now, you can just pull up those messages and get a little more information about them. And then finally, the config tab here, this is where you can actually assign those key bindings that I kept mentioning. So you can change the default ones that I was using, or there's other ones that aren't bound by default, such as e-stop, cycle start. So these really can help make a custom interface. And then you can change your units by default. We've got a lot of inches and feet, but you can set them to metric. And sound, we wanted some kind of feedback in a shop environment with touchscreen devices, especially when you're just kind of touching your screen, not touching physical buttons. You'll hear clicks to be able to get some kind of feedback. If that's annoying, you can turn it off, or you can control the volume and make it louder. And then this is the server tab here under config. Is where you can update your software. And this is a really robust update mechanism. So if you start the update process and pull power from your machine, it's not going to leave your machine in an intermediate state or broken state. It will remain on the current version. And if you start the process up again, it'll pick up where it left off. Bit of information about the Pocket NC here. So it all runs off a micro SD card now, and we ship it with a 32-gigabyte card. So you should have a lot more space for G-code programs than you did in the past. And then any IP information about how your machine's hooked up to the internet. And then down here is all of your calibration information. So you can, I generally shouldn't need to interact with this, but you can. So that's the overview of the machine.
There's a couple questions about the gauges, so calculated value, and then Mark just asked based on program parameters or sensors.
Yeah, so the sensor values are calculated. So this one isn't based on sensors, but just based on where the position of the machine is. Like it knows instantaneous velocity, and it takes the instantaneous rotational velocity, instantaneous linear velocity, and calculates an instantaneous feed rate of the tip of the tool, like instantaneous linear velocity of the tip of the tool. So that's what this value is in the feed gauge. Your commanded feed rate is down here in your active codes. So that F0 currently, we don't have an active feed rate. We do have plans to put it in other more present, make it more present in other locations. But for now, this is a calculated one. The commanded one's down here. Same with the spindle speed. Your commanded spindle speed is down here in your active codes. This is if you have the sensors on your machine, a calculated spindle speed. Were there any others?
There's just one more about tool change commands and prompts. We can answer some of these at the end, actually, if we want to do that.
Yeah, let's move on to Q. Let's make sure we get that going.
Yeah. Okay, so now let's see. We will turn it over to Q.
Hey, everybody. Like Carrie and John said, thanks a bunch for joining us. We're excited to explain some of the details on the new Kinetic Control and all the features that will hopefully benefit all of you guys and your machining on the Pocket NC machines. Today, I'm just going to basically talk about one of the biggest features, TCPC, Tool Center Point Control, and how it differs from the old way of programming on the Pocket NC, and then some of the advantages that you will see when using that feature of Kinetic Control. So to get started, I'm going to share my screen here with you. So based on the poll, it looks like most of you guys are experienced Pocket NC users. We do have a few out there that haven't used the Pocket NC, it sounds like. But I'm going to do a quick overview on basically what programming for the Pocket NC looked like previously. I'm going to use Fusion 360 just because that's what we use here, but the concepts are the same across different CAM softwares. So basically, the way we used to have to program our toolpaths and create G code for the Pocket NC was we had to have a work coordinate system origin based around the center of rotation of the machine. And that center of rotation is represented by this dot here. And basically that's the center of rotation for A and center of rotation for B and where they meet. And so that's the ultimate center of rotation for the machine itself. The reason we had to use that point is so that in any position that the machine might be in, basically the machine knew how far to move from that point to make the correct power or move to make cuts on your part. This worked well. It allowed us to provide a 5-axis machine and perform 5-axis moves, but there were some downsides to it. Basically, with this point being this kind of floating point in space above the B table, which is represented here, we had to make sure that our part, as represented by this part here, and our stock were accurately positioned relative to that point. Anytime we created a CAM software, and then as well as in the real world. So that meant that both in the CAM software and in the real world, they had to be the exact same as each other. So that meant in the real, if in our CAM software we aligned our stock, which is represented by this sketch here, if we aligned it with these back 2 holes on the vise, in the real world we had to make sure that matched. Otherwise, if the stock was off by a set of screw holes, a set of set screw holes, when we set it up on the machine, the distance from this point to the face of this stock is different in our CAM software, where the toolpaths were created, than in the real world. So some of the challenges that came with that were we had to have access to a representation of the machine. In this case, our B table offset our B table, as well as our fixturing, in this case, our vise and vise adapter. So you had to have access to that from whatever fixturing manufacturer you used. And then you need to bring that into your file with your part. On top of that, we had to have a representation for our B table offset. Basically, that's the term we use for that point above the B table that represents that center of rotation. That's different from machine to machine. And so users basically had to have something that represented that, and then had to make sure that this line, or the distance from the surface of our B table to the top to this point, was the right dimension relative to your machine. So that had to be there, that had to be adjusted. And then finally, we had to make sure our stock was represented correctly, so that when we started everything off, the stock, and then in the end, the part was in the correct location and basically where the machine expected. This basically added a lot of steps on the front end of the programming process, which to some wasn't a huge deal, but where it really was a problem is if anything changed on the machine. Let's say I did all this expecting to be able to machine this out of a 2-inch cube, but then found out all I had is an 1.5 inches by 1.5 inches, or an 1.5 inches cube in my pile of stock in my shop. Well, now that changes where the faces of this cube are, and therefore changes the complete setup, which caused us to have to come back to basically the Fusion 360 or any CAM software and adjust basically adjust our cam to represent that new piece of stock. So now with TCPC, the new work coordinate system offset or work coordinate system origin can be set basically anywhere relative to the stock itself, or a part if you're working on a finished part of some sort. What this means is that this origin point, the point that all of those tool paths are calculated from, is relative to the part that you are loading on the machine. So that means that we can basically get rid of our stock representation. We can get rid of our vice adapter, our vice, our B table offset, and even our B disk, because all of our tool paths will be calculated from this point in space, which is a point we can locate on the machine when we go to set up. So this makes for a much easier or much more flexible tool path or tool paths in G code, because all we have to do is define this point on the machine to basically to run all the G code from that point. So you know, what that looks like on the machine side of things is we come in here and we go to our tool work offsets page. And this is, for those of you that have worked on other machines like 3-axis machines, this is probably going to be pretty obvious to you, but this is basically, we're going to come in here and set our work coordinate system or work offsets. And by, we can do touch offs, we can use an edge finder. There's a variety of different ways. You can use a probe if if you've come up with a way to rig that up onto the machine. But basically, that looks like something like this. So we are wanting to, you know, we load our stock on our machine like this, and we've got our X, Y, and Z coordinate system here. And that's that point that we defined in our G code, or excuse me, our CAM software. So we're gonna basically do some touch offs on the machine to define that point on the part itself, on the machine itself. So for instance, here, this is what using the paper trick is what I like to call it, would look like. We're using an 1/8 inch dowel, something of known diameter. We're creeping up on the part, and we are basically creeping up in small intervals. Usually by the time you get close, it's about 1,000th of the time. And we're basically going until that piece of paper, which is a known thickness as well, will not slide between the part and the tool. That tells us that we are now, the center of our tool is now the radius of the tool plus the thickness of the paper away from the face of that part, this face here, which represents the X origin point. So in this case, you know, since we don't need to be super accurate, since we've got stock on all sides of our part, what it really looks like is saying, okay, for the x-axis, I am negative 0.0625 away from where I want to call 0. Basically the radius of the tool, and we're on the negative side of that. So I would click set. You can see that an offset gets put in here, and that's basically the distance, the difference between what we just put in and where we were from that center of rotation point that the machine knows as the origin point of the machine. But now you can see our DRO reads negative 0.0625, representing that it thinks that the x-axis is at negative 0.0625 because we've just called the face of that part the 0 point. So hopefully that kind of makes sense. Then you can basically go along and do that for the y-axis. You do the exact same process here. And then the z-axis is a little bit different. We basically just have to account for the tool length offset so the machine knows essentially where the end of the tool is. We've improved that process quite a bit in Kinetic Control. You know, this tool is defined as something in our CAM software, probably like, for instance, I think in this operation, it was tool 10. So all I have to do is come here, make sure my tool 10 is measured by using the tool measurement, the automatic tool measurement and tool probe button. And then I just need to make sure that that's active. So once that's active, the TLO will read tool 10. We get a number here that matches our tool length offset here. I can use this to set this as, in this case, it would be 0 because there is no radius to account for. The end of our tool is directly touching the end of, or the face of our part that we want to call that Z0 point. So I'd hit set, and now that's taking into account, that's basically calling that that face, the 0 point for the Z axis of the work coordinate system with the tool length offset taken into account. Before we had to, in order to do that, you had to actually run a small chunk of G code in the MDI command. So we've simplified this significantly by making this button available for activating a tool before setting those work offsets. So the reason this basically makes this easier is now if we move our part in our stock or in our fixture, all we have to do is change our work coordinate system or work offsets in the UI. And I've actually got a video here for that to represent that. So I will run that now and kind of talk over it as we go. So here, basically, we're starting off in the home position, and I have set my work coordinate system just like we shown in that previous picture. Work coordinate system is set here, and we're going to run just some real basic G code. I'm going to carve my name into the top of this block, and then I'm going to put a chamfer on the top of the block using a 5-axis swarf. So we've sped this up just a little bit to kind of save some time. So you can see works just like normal. This is exactly what we'd expect for tool operations with it set up the way we showed previously. So now what I'm going to do is I'm going to open up the device, and we are going to basically move our gripper set screws here in the vise. We're going to move them back one set of basically whole set. That's about 0.2 inches, and that'll be a movement in X, in the X axis. Previously, something like this, if you needed to make this move, you would need to go back into your CAM software and adjust the whole model back one set of screws or one set of holes. In this case, we can move the set screws, reposition the stock. It didn't technically move in Y, or didn't move much in Y. You can see I'm realigning it just with little dents here. Not the most accurate, but for representation purpose, we can say that Z didn't move. Y obviously didn't move because we're referencing the bottom of the block, but X moved about 0.2 inches in the positive direction. So to compensate for this, instead of going back to the CAM software, all I have to do is come in and bring the tool in. And in this case, I'm using, instead of the paper method, I'm just using the just kind of raw touch off method. So I'm just creeping up on this part until I, and turning the tool until I get a slight cut on the stock. That tells me that my tool is just barely engaging with the stock. So you can see that shard there, kind of shows right there. So I've just done a touch off. Now I'm going into the user interface, and I just need to basically redo my X touch off, like just like I showed you earlier, but only in X because that's the only direction we've moved. This is still an 1/8 inch tool, so we're doing a negative 0.0625. Now we can run the exact same G code, didn't have to output any different G code, and we will get the exact same tool paths and cut in the exact same spot. You're going to see a little bit of some chips come off here solely because this isn't a super accurate way to redo a touch off. But you know, you can tell that we're cutting in basically the same spot, certainly not 0.2 inches off. So this drastically improves the flexibility of stock size, fixture, all sorts of things, without having to go back into your CAM software and make all those changes and output new code. And the cool thing is, you know, this is something that we had kind of previously released, probably 6 months ago with RWO and the old controller, but that only worked on 3+2 machining. TCPC and the Kinetic Control allows us to do this with 5-axis moves, as shown here with the swarf. And I think that about does it. That covers pretty much everything to know about the TCPC and kind of the general setup of it. One other handy piece of that is that now the DRO values that you see from that point are tangible. You can understand that when you see negative, that your tool is negative 0.0625 in X, you know where that 0 point is. You know that you are 0.0625 from that one corner of the stock. Helps a little bit with watching your machine and making sure that the machine is operating the way you'd expect. And if you've got any questions, feel free to throw them in the chat. We will answer them at the end here.
Great, thanks, Q. Yeah, so you can find more detailed information. I'm just going to throw this in the chat at pocketnc.com/kinetic control. And so we're now shipping all machines with Kinetic Control. That's been the case since November 1st. If you want to upgrade to Kinetic Control, we're shipping out SD cards. If you're not in the United States, you can just email me at the email I just put in the chat, info@pocketnc.com, and I can walk you through a digital download. We are just doing that for people outside the US. Let's see. So we have a lot of written resources in our user resources tutorials section, so you can go through that. A lot of what Q and John just went through is in there as well. And we do have a new Fusion 360 post. It hasn't officially been released into Fusion, but we have it available for download from our homepage. If you go to Help Post Processors, you can download it from there. Mastercam is in progress. We're not quite sure when that's going to be released yet, but if you bug them, they might be a little bit faster. But yeah, thanks everybody for your time. And we will answer some questions now, but if you have to hop off, you can. And I will send the replay to everybody. I can do that. Yeah, so let's see. We'll maybe work from the oldest questions up. So John had a couple of things that he was taking notes on, and then we can kind of work through the ones that just got put in the chat as well.
Yeah, so can G-code be run from a specific line? Not currently. We have a number of improvements we want to make to the G-code pane here. And running from a specific line is one of them. We also want to allow editing of the G-code and stuff like that. But yeah, that didn't make it into the initial release. Tool change prompts, those also haven't been changed, but here you can, let me just share my screen really quick. So if you go, you can in your code just put like a debug message. So your current tool number is so our active tool is number 3. So we could simply add that line to the tool change process, something like that. You can also add that to your post processor if you have, if you want to stick in some manual G code. that debug message can be handy. Yeah, that's something that we could easily add in there, but haven't yet. Do we have any other? Those are the only two I wrote down because they got lost. But
let's see. Is Kinetic Control software created solely by Pocket NC? Mark asked that. Yeah, we did.
Well, I mean, it is very much open. We rely heavily on the open source community, so we did not develop all of it, but yeah, we put this unique combination of technologies together.
And then, so we sell an edge finder for the V2. I'll turn off screen. We do sell an edge finder for the V210. We don't have one for the V250, and that would be in the store. V210 accessories is where you can find that. Paul asked what's involved in the upgrade. So it's just, we would mail you an SD card and you just plug that into the BeagleBone board. I don't know if you want to show the one we have, John. So it's really easy. You just plug it in and we'll send you instructions.
And with that, that actually answers another question that was asked. Is it possible to get back to the old UI after upgrading? It is, because you can simply remove that SD card and revert back to the old UI in the case that you'd prefer that or need to use that in some way.
So we've got a question. Can you describe more specifically how power, load, and temperature are calculated? So those aren't calculated values. Temperature is only shown on machines that have a temperature sensor. So the V250 has temperature and actually pressure as well. There would be an extra gauge up in the upper left corner. So machines that don't have a temperature sensor, that will just remain grayed out. Same with power and load. And we don't have any machines in the field right now with power and load that is hooked up to those. That's more for planning for the future. Our most recent V2s do have the sensors on them. We just need to hook those up. So look forward to that.
And yeah, so if you you have to use the posts required for TCPC to not use the machine center of rotation. So you can still use the traditional method, even if you're using Kinetic Control. You can use the previous method, not traditional. Yeah, both are available on Kinetic Control. You just have to be aware of how you're setting up the post. Let's see. And did we miss any? Q, do you see any other ones?
People did. I mean, Matt answered it in the chat, but B-axis unwind, there have been improvements on that. I can demonstrate it too if they want to see it. There's a new code that can allow so the B-axis is a continuous axis, right? So you can do like M999 P2000. If I wanted to get the B-axis wound up to 2000 without actually needing to fully rotate multiple times, I could issue this command and the B-axis will instantly go to the nearest angle to that location. So 2000 wasn't a multiple of 360 degrees, so it went to the closest location there. Sorry. I could follow up with a B2000, G0 B2000, and it would go the shortest distance to that location. So post-processor will have to implement that code to properly unwind quickly, but it is a built-in feature now.
Okay, and then actually Olivier had a bunch of questions. So, so for programming the manual of the Kinetic Control, in our user resources, there's several written. There's an overview of Kinetic Control, and then the first part tutorial now handles how to program using Kinetic Control. So that's available. We're going to be updating our video resources next month and the course as well, which will be relaunching in January. The ETA on the Mastercam post, I don't have that right now. I'm hoping really soon. We did email them. And then, John, do you want to answer the other ones?
So there is a distance to go on the production tab. So yeah, I guess we need to add that on the manual tab. But while you're running a program, you can set your DRO to distance to go, and it will show how much is left in the current line.
Can you maintain a constant feed rate at tooltip? That was the second question.
Yeah, I mean, that's pretty standard. So you can set your feed rate. That's determined by your post processor. So yeah, yeah, it's up to the post processor to properly get your feed rate correct.
Okay, and then can it do millimeters? I think that's what MM is.
Can do millimeters, yeah. So G21 is a standard way to program your part in millimeters, and by default, the units that we show are program units. So whatever your program is programmed in. So if it's G20, it'll show in inches. If it's G21, it'll show in millimeters. Either way, you can override that. If you always want to show it in millimeters, even if it's programmed in inches, that's fine too. But yeah.
And then a couple of questions about the upgrade. So you can purchase an SD card. Right now it's $200 through the month. It's $250 for Kinetic Control on V2s starting December 1st. All the new machines will have Kinetic Control this month. They're staying the price that they were, and then they go up in price on December 1st. Those prices are reflected on the website. Let's see.
It looks like there was still a question on tool comp wear control. I don't see an answer to that. So inside in the setup tab in the tool table where you can choose your tool diameter, and John, correct me if I'm wrong, but that can be used to comp for wear. The trick there is that your CAM software does have to be set up to look for that diameter and output the correct code that looks for this diameter instead of just assuming that it's a nominal number. So hopefully that answers the question there.
Right. So there's no wear column like on other controls. You have to manually incorporate that into your diameter, and then there is tool length or cutter compensation codes. I think by default, the Fusion 360 Post generally doesn't use those, but I think certain post processors can leverage those codes.
And then Oliver asked if we're making a probe for the V250, which at the moment we're not, but somebody has put on, somebody's written a blog post about how they've retrofitted theirs. So I think if you just Google V250 Pocket NC probe, you'll probably happen across that blog and see how he did that.
Yeah, so the software is set up to work with a probe if it's hooked up to the right signal. So the button that you probe the tool is the right electrical signal. So people have kind of spliced into that signal. At some point, I think we would like to have our own probe, but we don't have a timeline on that.
And the new machine is still sometime next year. Yeah. Okay. Great. So I think tool diameter cannot be 0. So it would be, I'm not quite sure what that means. I can't put tool diameter to 0.
I'm not sure what you're asking.
Yeah,
tool diameter can't be 0. So by default, they're all set to 1/8 of an inch.
I think you might be referring to when you set a work offset, the 0, I believe he asked a question earlier, or somebody asked a question earlier about, yeah. Oh, and tool offset. Maybe not. Maybe I'm not tracking.
Olivia, we can follow up via email or phone with you to answer your question because it seems like we're not quite grasping that. But yeah, feel free to send us any follow-up questions, info@pocketnc.com, or our phone number is also in the contact us section of our website. And I think we'll wrap it at that. So yeah, thanks so much for spending the time this morning, and yeah, send over any questions. We appreciate the feedback. All right, thanks.
Thanks, everyone.